In previous videos, we walked through the small sample procedures for mu1 minus mu2, but we made the assumption that sigma 1 squared was equal to sigma 2 squared. We cannot always necessarily make that assumption. So in this video, we're going to walk through what we can do when we don't make the assumption that sigma 1 squared is equal to sigma 2 squared. So when sigma 1 squared and sigma 2 squared are not equal. We're first going to look at when we have equal sample sizes. So when we have n1 is equal to n2, which we're just going to define for that single value as n. So first we'll walk through our confidence interval. We have our confidence interval, Ci, and it starts off the same. So we have our x1 bar minus our x2 bar and plus or minus our t sub alpha over 2. So at this point we're doing the exact same confidence interval, but now we have a slight modification to what our standard deviation is going to look like. So our standard deviation is now going to be s1 squared plus s2 squared all over our n value. So again, this is the n where it's equal to n1 or n2, and we take the square root of all of that. And that's going to be our new confidence interval for our mu1 minus mu2. Now we're going to take a look at our changes that we're going to make for our hypothesis test, so ht. And our hypothesis test is going to be testing again h0, where we're going to say mu1 minus mu2 is equal to 0, which is going to be our d0 value. And the change that we're going to make here is just a change to our test statistics. So we're going to make a change to t. We're going to say t is equal to our x1 bar minus x2 bar. And all of that is going to be divided by our square root of s1 squared plus s2 squared, and that's sum over n. So again, that n is either n1 or n2. And the final piece that we need to know is the degrees of freedom for t. So our degrees of freedom for our t value is equal to our n1 plus n2 minus 2, which is also equal to 2 times n minus 1. So again, that n where n is equal to n1 or n2.